Previously, we saw a binary search implementation for the flight path problem. Uh, a student brought up an alternative implementation, which I thought is very interesting, very concise, but a little bit different from what we have done. And hence, I thought it's good to look at it closely. So let's briefly look at this. Basically, we have this altitude search function again to list altitude being passed in and a threshold. I set up my left and right pointers like usual, but notice now the while loop is running basis just these two pointers. So while left is less than right. Now what this means is that this loop is going to terminate when left becomes greater than or equal to right. Well, more likely left becomes equal to right because this is a less than. And while this condition is true, the loop keeps running. The condition becomes false, the loop terminates, like a regular while loop. So this is something interesting. Mid is, of course, left plus right, floor division 2. This is what we do, and this is logical. Now, if I find that my altitude at the mid value, remember, always check at mid, is more than the threshold, I know that I need to be searching towards the left. So what I do is to bring my right equal to mid, else I move left to mid plus 1. Now this is something interesting again. Right is being set to mid, left is being set to mid plus 1. We'll see why this is significant and how this works. In fact, we'll see later on that not having this will cause an infinite loop. And finally, you notice that the return value is not the mid, but in fact the left. Again, we try to understand this by the working of the code. So let's run this code and see how these pointers are moving so that we get a better understanding of how this whole thing works. So here I have implemented that the same function. So I've called it altitude search, altitude and a thresh. The only thing different here is that I've added some print statements so that we can see how these pointers are moving, because remember, everything is now basis these pointers. So I'm just going to run this code for several examples and we'll see how the code behaves. So basically I've got a list here, let's say 0, 11, some standard list that I've been using. Let's say the threshold is 50. When I run this, so I get my answer to be 6, which is indeed correct because 0, 1, 2, 3, 4, 5, 6, indeed what I wanted. Remember, first we start like regular. So I search at mid, which is 4. So my value 0, 1, 2, 3, 4, that's 38. That is below the threshold of 50. So I know that my search zone has to be on the right side, which means that I go and update my left pointer to mid plus 1, that is 5. So 5, 9, and 7. I search at 7. Remember, 7 is basically more than 50. So I go and set my right pointer equal to mid. Notice this was mid plus 1. This is equal to mid. So that's 5, 7, 6. I search at 6. I find that, look, 6 is, still more than 50. So I make my right pointer 6. Then my search zone is at 5. So I search at 5, which means I search at 49. At that point, remember, I'm going to make left mid plus 1. The moment I do that, my left and right become equal, the code terminates. Because remember, while left less than right. So code terminates and 6 is indeed my value that I wanted to return. That is the value I return. So this is working correctly. The point is basically the way the loop terminates is when left and right become equal. And at that point, I'm not interested in the mid anymore because I know that I've crossed the threshold and come to mid plus 1 is the threshold crossing point, and that's what I'm returning. And hence I return a left over here. Now, let's see what happens if I were to give a value, which is, let's say, more than the threshold. So, sorry, more than all the items. So let's say I say 500 here. Now, in our case, previously we had handled it separately, but this code is quite interesting. In fact, this will take care of the situation. Basically, when I do this, so you realize that the code keeps working exactly the same. I come to a point where my left, right, and medium are 8, 9, and 8. Now, at this point, remember, my situation here is that altitude is less than the threshold, which means I increase my left and hence my code terminates. So it returns 9 because remember, left was 8 here. So I return left, which is 9. But of course, I can handle this, separately, just to illustrate, right? What happens if I were to give, let's say, minus 10, right? So I say minus 100, right? In this case, I expect to get a 0 because once again, the same situation is going on. I go and search at 0. I find that, look, I'm greater than 0, basically greater than the threshold. So I go and set my right to medium, left and right become equal, and I terminate. Very interesting to think about how this thing is actually working. However, let's see what happens. So let's say I set this to 50 once again, but let's say I go and change this to say mid. Now this is very interesting. In fact, we'll end up in an infinite loop, as we'll just see. Basically, what's going on is, this is now running forever, so I'm going to have to stop it, because essentially this is just in a loop forever. Remember, I'm searching on 5 where I am less than the mid value, less than the, I'm searching at 5 where I'm less than the threshold. So I go and set my low to 5, and I'm forever in that loop, because this is exactly what we had seen earlier, right? Which is why here we need mid plus 1. But other than that, this code is really nice, really concise. But again, the broad point here is this, that binary search, can be written quite concisely, but be careful. Do look at the movement of the pointers, because that's when we get confidence. We start understanding the different scenarios in which the code is working, because easy to make mistakes. I hope you found this interesting. Do look at our website www.ybyte.in for more such content, and enjoy programming. Take care. Thank you so much.